be Tuesday evening. So, announcement before we get started. I will not be here on the 31st.
Are you trick-or-treating?
My kids are. Plus they're doing something after school. So. That is, of course, the day that we cover triple integrals. It's 2 days before the test. So I don't know what I'm going to do. I either post a video and then continue the review on Tuesday as originally planned, or just skip the review and cover what I was going to cover on the 31st, that Tuesday. We'll see. I'll make a decision as that day gets closer. So we had the idea of a tangent line when we were dealing with curves. Right, and that's what dy dx represented, right? It was the slope of that line. Well, we also have now the idea of a tangent plane for a surface. It's just as it sounds. It is a plane tangent to the surface at a point. Right. More specifically, it is the plane that contains all of the tangent lines to the surface at that point. The equation of the tangent plane would be z equals f of the point plus the partial of f with respect to x at the point times x minus x naught plus the partial of f with respect to y at the point times y minus y naught. Total differential so let's say we have a function z equals f as a function of n independent variables. The total differential is the sum, I equals 1 to n, partial of f with respect to x sub I times dx sub I.
This sum, does that go with just the partial derivative?
I is the dummy variable.
But is it the sum of everything to the right of the summation sign?
Mm-hmm.
Okay, thank you.
In multivariate, we now have special chain rules. we technically don't have to use. So suppose that x and y are both functions of t, specifically they're differentiable functions of t, and that z is a function of x and y, and it's differentiable. Then z is a differentiable function of t. And the partial of z with respect to t would be partial z with respect to x times dx dt plus partial z with respect to y times dy dt. And then this can be extended to any number of variables. Right, so if you have a four-variant function, but each of the four independent variables is a function of a single independent variable, you can still use this chain rule. Right, you just extend it. Now, why don't we need to use it? Well, couldn't you just substitute the functions in for x and y at the start, and then it's just account for one function that you take the derivative of? Right, it'd just be f of t at that point. Because both x and y are functions of t. So just substitute it in first and then take the derivative. But why stop there? Why not say that x and y are both functions of two independent variables? Call them u and v. Then you have a partial of z with respect to u and a partial of z with respect to v as given there. But again, you could just substitute x and y, your functions in for x and y, and then find the partials normally. Why stop there? Why not make each variable, each independent variable, a function of three independent variables? Or why not make z a function of three independent variables? So here is the general chain rule. But again, you could just substitute each of your functions in to your independent variables and then use partial derivative as normal. So why do I even introduce these? Why do I even cover them if they're not really necessary? So glad you asked. It's not because I'm told I have to. Remember in Calc 1, I actually just did this today in Calc 1. You're given a curve. Is every curve defined by a function? The easiest one is a circle. Circle's not a function. But you can still find slope at any point on it, can't you? How did you find that slope? So let's keep it simple. An arbitrary circle centered at the origin of radius r. What is its relation?
X squared plus y squared equals r squared.
How do you find dy dx of that relation?
Plus.
Y is an implicit function of x. Can't we have z implicitly defined in terms of x and y? Or w implicitly defined for x, y, and z? Oh, well then how would we do it? We have to use implicit differentiation. Now, do you remember the steps for implicit differentiation? What was the first thing you did?
Well, the ones that have, like if you're doing it with respect to x, and you have terms that are clearly x, that are easy, you just do the derivative for those, like you always would. I'm not saying this very mathematically, but that's how you start it, right?
Technically, no.
Oh, okay.
You're doing that because you're doing something else. You take d dx of both sides. Right, and then, of course, you use your normal rules with chain rule. And that is the only calculus. Because then you have to algebraically solve for dy dx. Well, the same thing would be true here, right? So let's just say you have some function z implicitly defined in terms of x and y, and I ask you to find partial z, partial x. You just take partial x of both sides of the relation, and then algebraically solve for partial z, partial x. Or we can use chain rules to prove an easier method, which is what I do. Going back to Calc 1, with multivariate, we no longer have to do all of that nonsense. Just write your relation in the form z equals f of xy equal to 0. Then your dy dx is that term. Negative partial f partial x over partial f partial y. No more algebra. Don't you wish you would have had this in Calc 1 when you had to do implicit? became what was a multi-step process that could take you several minutes to complete because of the algebra is now a 5-second problem. And it's usually a single step. And this, of course, can be extended. If you have a two-variant function that's implicitly defined, these would be your two partials. And then obviously you can see in natural extension you have an implicitly defined three-variant function. Then you have three partials. They be defined in much the same way. So find the total differential. And remember, that's the total differential. For this case, because it's two variant. What is the partial with respect to x?
3x squared y plus 2x y squared plus y cubed.
Now, what is the partial with respect to y?
X cubed plus 2x squared y plus 3xy squared.
dy. And there's your total differential. There's your dz. That was easy. The Staples still have that button. Because if so, I should get one and carry it with me.
They probably do still sell it.
I should get one.
They don't, somebody else does.
Carry it with me. I can probably find it on Amazon. So. Well, I should be careful with Amazon. I should test it first. I might get one that says something I don't want it to say. What's the total differential?
sine of y minus y cosine x plus x cosine y minus sine x.
Like that?
Oh, parentheses around the first two terms, and then dx, and then parentheses around the last two
See, now,
terms.
now you're making me not have enough room. Lucky for you, technology's a thing. I think you have to throw some black mambas on with your Well, that's interesting. Division total differential. Partials are so easy. That's okay because next week we hit that Grand Canyon cliff. So we finish multivariate functions this week. Next week we start integration. Let f of x, y, z be a differentiable function. We want to evaluate the partials in spherical coordinates. I'm going to get this set up because I am going to need it. How are we going to do this? First, what is x?
I forget what the symbol that looks like a P is called, so I'm just gonna call it P. P.
And that makes me very sad.
Yeah, I know.
Every time you call P, I'm deducting 5 points from your total grade.
Oh, really? Man. Alright, I'm gonna get enough then, just how it is. P times cosine theta times sine phi.
There's 5 off. What's y?
Rho sine theta sine phi.
What's z?
Rho cosine phi.
You may have also just offended every single Greek. I actually don't know how they feel about that. Next time I see a Greek person, I'm going to ask them. What's your opinion of people calling rho Katie?
My grade econ professor is Greek. You want me to ask him?
Go ahead. See what he says. But then I his actual response. For all I know, he could threaten to shank you, and you just tell me, "Oh, they don't care." It's true. Come in. I fell down a flight of stairs, and he didn't care. We have to use those and the chain rule. So first, partial F, partial rho. And this is where I said the two notations are interchangeable. That's what the chain rule says. Partial of f with respect to x times partial of x with respect to rho, plus do the same thing for y, plus do the same thing for z. What is the partial of f with respect to x?
F of 1, 0, 0.
It's a trick question. It's partial of f with respect to x. Because we don't know what f is. What is the partial of x with respect to rho?
Is it cosine of theta sine phi?
Why, you're asking me.
Oh man. It is cosine of theta sine phi.
What's next?
Well, sine theta, sine phi, df, dy.
Oh dear.
Or is that partial?
It's partial. Or del. Bless you. What's next?
Cosine phi, partial of partial.
So I'm just going to rewrite it. Now there is something you do have to do. You'd have to evaluate those three partials at x equals rho cosine theta sine phi, y equals sine theta sine phi, or rho sine theta sine phi, and z equals rho cosine phi, right? You can't leave x, y, and z in your partials. That would be the only other thing you'd have to do. Let's see how good this turns out. Yay. Very important, especially in general relativity. which I'm not sure if they still offer here. Maybe in quantum too. Quantum meteors, field stuff. Now, partial F, partial theta would be what? Would be that, wouldn't it? What is partial F with respect to X?
Minus rho sine theta sine phi.
I said partial F with respect to X.
I thought you spoke.
No, I didn't.
We wrote on the board.
I said partial F, partial X for a reason. To see who's paying attention.
I caught it, but
Apparently no one was paying attention. That makes me sad. Just partial F, partial X. And we don't know. Now, what is partial X, partial theta?
minus rho sine theta sine phi partial of partial x plus rho cosine theta sine phi partial of partial y plus 0.
Partial Z, partial theta is 0, isn't it? So it pulls out the high root. There's only one left to find now, right? And how do you think we're going to find it?
Rho cosine theta cosine.
So don't give it to me just yet. How are you finding it?
No. Same way I found the other ones.
Which is how? Well, it can't be the same way,
Well,
because those are two different ways.
you take the partial of phi, or partial of x, y, and z with respect to phi.
So give me the formula.
Formula or f plus, how do you say that? Just fy or
Yeah, Fy, F sub Y, whatever.
fy, y phi, or y phi plus fz, z phi.
There's only one pun person in this room.
Is it you? Yeah.
Just like there's only one person who's allowed to make dad jokes. That's me. At least in this room, outside this room, you can do it.
I was
You
gonna
know
say,
what,
just
I
like in the world or in this room?
Just in
What
this
about
room.
my joke from last week?
And math puns and math jokes.
You're the only one allowed to make math puns?
Yep. In this room.
That's sad.
Just in general, there's only one person allowed to make jokes. Everyone else has to be serious, right? This is a very, very serious business.
Of course, of course.
See, world here. So now, what is it?
cosine theta cosine phi partial f partial x plus rho sine theta cosine phi partial f partial y minus rho sine phi partial f partial z.
There are your spherical partials. Again, they are extremely important in the study of physics. Now we're given a function, simple function. Find the spherical partials. Make life easy and first find the three ordinary partials. Let's call them rectangular partials. So what's use of x? Use of y?
Or what?
Use of z? Use of rho? What did we say it was?
It's cosine theta sine phi partial f partial x.
Which is what? In this case.
2x plus sine theta sine phi times 4y plus cosine phi times 4z.
But we can't stop there. Because now this whole thing has to be evaluated. Right this way. In spherical coordinates. So I'm just going to represent it that way. Just for the sake of space. And so it becomes 2 rho cosine squared theta sine squared phi, right? Plus 4 rho sine squared theta sine squared phi plus 4 rho cosine squared phi Can that be simplified?
Well, you can factor out a 2-row.
Is there any other simplification?
You could factor out well, for the first two terms, you can factor out a cosine squared of beta. Oh wait, never mind.
There's no other simplification. Which means factoring out that 2-row serves zero purpose. So I'm not going to do it. What about u sub theta?
Do you want like the general equation or the answer?
Before we evaluate in spherical.
Alright, I got you. So that is negative rho sine theta sine phi 2x plus rho cosine theta sine phi 4y plus 0. I like that.
So we won't write it out. And then this one has to be evaluated. In spherical coordinates. Can this be simplified?
It's just 2 rho squared sine theta cosine theta sine squared phi.
Can that be simplified?
Probably sine cube, no, no.
just so nice. There's your hand.
So, guess I can see that.
Is it, innocent question. Sine theta, cosine theta, that's sine of 2 theta over 2.
You said you weren't going to answer me a question,
Yeah, I stated it, wasn't it?
which means
Rising
it's not a. It's a question, not a statement.
No, I didn't ask. I didn't ask. I just said it with a.
Is a question.
Which makes it a question.
It wasn't.
You may not have asked it to me, but it's still a question.
Is it, rho squared sine 2 theta, sine squared phi?
Why are you asking me a question?
I'm not stating.
Okay, well, that wasn't a statement. It didn't sound like a statement.
Rising connotation.
It's because I'm not sure the name of that P, and I keep, it makes it sound like a question every time I say it, because I keep forgetting the names for some of these subjects.
You don't have to worry about it. If you say P, he's losing 5 points.
Oh, I'm the only one who knows that. I was unaware of that.
Every time someone says P, you lose 5 points.
I didn't know that that's how it worked. I thought it was just me.
I thought it was directed at the person, not at him.
Things like rho squared sine 2 theta sine squared phi.
Too bad you said I think. It's just that I know. There you go. This looks much nicer. So I think you're up to 15 points right now. I think 2 more were said. I could really even say every time I say it too. There's one left. You or Fee? This one's fun. Do I have enough room? I won't know to find out. We're at 2 spherical, and I will not have it. Can that be simplified?
We have the first. Oh wait.
Back down to sine phi, cosine phi, we get a sine phi, cosine.
Not a sine 2 phi. Half of sine 2 phi. Sine of 2 theta is 2 sine theta cosine theta. So if I do that, I'm actually not going to factor it out right now. Just replace every sine phi, cosine phi with sine of 2 phi over 2. Now what?
With factor out a rho squared sine 2 phi, you get that times cosine squared theta plus sine squared theta minus 2. Oh, 2%.
epic than that.
Difference is squared.
1 plus sine, oh, sorry. Sine squared theta minus 1
Where,
in those parentheses.
which part though?
I changed cosine squared theta to 1 minus sine squared theta.
Okay.
And then we're adding. So 1 minus sine squared theta plus 2 sine squared theta. 1 plus sine squared theta, then you have that minus 2. So sine squared theta minus 1.
Which is cosine squared theta. Oh, that's one. Negative cosine, be negative cosine squared.
But you did more than you had to do. Well, you're not incorrect. Why replace cosine squared theta though? Isn't that negative 2 cosine squared? Trig is sexy.
Not sure I've ever heard that sentiment before.
Then you haven't been around the right people.
Hey, could you say that again? I think I misheard you.
Probably didn't. Trig is sexy.
Okay.
What kind of function do we have here? So we're going to have to do a technique. Implicit. But we have the shortcut now. First thing you want to do is write your function as a 3-variate function. And it has to equal 0. So what's the function? There's your function, and that does indeed equal 0. Partial z partial x would then be that. What's f sub x?
Y cosine xy plus 0 plus z cosine cx.
What is f sub z?
Y cosine yz plus x cosine zx.
So there's your partial z partial x. I'll let you verify it algebraically. Partial z partial y, what's in the numerator?
X cosine xy plus z cosine yz.
Is your partial z partial y. Much easier than what we had to do in Calc 1. Because that's the formula. It is derived in the lecture video. As to why, as to where that negative comes from. So I'd recommend go watch that. So what we're going to do is we're going to show that if we're given a surface of the form f of xyz equal to 0, then the tangent plane at the point x0, y0, z0 can be given by that equation right there. Oops. we're going to do is define some arbitrary curve, call it R, on our surface that passes through the given point. At P, we must have the derivative equal to 0. So fx x dot plus fy y dot plus fc z dot has to be 0. But that means that dot product has to be 0. The dot product is 0, then the two vectors are perpendicular. This vector right here is the derivative of R with respect to t, right? Well, that would just be the direction vector for the line that is tangent to R at your point P. Which has to lie in the tangent plane. So I'm going to actually reword that. It lies in the plane that is tangent to our surface at the point. So then that vector, which was perpendicular to the direction vector, lying in the tangent plane, would have to be normal to the tangent plane. That's our normal vector. Oh, but what is the equation of a plane? How do you find it? Yes, what is D though? So don't give me that form. That was the general form, right? Give it a standard. Standard form. A times x minus x naught plus b times y minus y naught plus c times z minus z naught equals 0. Oh. Which is what we wanted.
Could you go through this one again? I'm a little lost.
So pick an arbitrary curve. Right. Tangent at, or it's on F, it's passing through P. Right, so just pick a curve. Its derivative. I'm skipping ahead. At P, that equation has to be 0, right? If you take the derivative of F using chain rule, have to be 0, right? Because F is 0. So that's where that comes from. Because now we're saying x is a function of t, y is a function of t, and z is a function of t. Right? Another way of saying that, if you look, isn't that a dot product of two vectors, which equals 0? Which means your two vectors have to be perpendicular. Right? A dot product of 0 means the vectors are orthogonal. But that x dot y dot z dot is r dot, right? It's the derivative of r with respect to time, which gives the direction of a line tangent to your curve r at, right? Remember that?
I'm sorry, say that part again. I was writing something down.
The derivative of r is the direction of a line tangent to r at the point. So that's a tangent line, or that's the direction of a tangent line.
Yeah.
But that has to lie in the tangent plane.
Yeah.
Right? Well, didn't we just say that fx, fy, fz is perpendicular to our tangent direction vector?
Yes.
And if that tangent direction vector lies in a plane, then it would have to be normal to that plane, right?
Yeah.
That means that is the normal vector for the tangent plane.
Okay.
Now it's just, remember how we found equations of planes? You needed two things. You needed a point in the plane, which we have, it's P.
Yeah.
And you needed a vector normal to the plane, which we now have.
Okay.
Then that's the equation. And so we're done. Now I'm going to be using that. We're given two surfaces, F and G, and we're asked to show that those surfaces are tangent to each other at the point 2, 1, 1. If the surfaces are tangent at the point, what can we say about the tangent planes? How do they intersect? So they would be the same tangent, right? They'd share a tangent plane at that point. So to show that these two surfaces are tangent at the point, it suffices to show that they have the same tangent plane at the point. Which means that your normal vectors are parallel. What does it mean for two vectors to be parallel?
They differ by a scalar multiple, or they're scalar multiples of each other.
One's a scalar multiple of the other. So all that was the setup. Normal vector for F. So let's call it n sub F. Well, the proof that we just did tells us what that vector is. It's that. So what's f sub x? What's f sub y? What's f sub z? And that gets evaluated at the point 2, 1, 1. Four, 8, negative 8. Normal vector for G. Would be that, right? What's GX? GY. What was it? And what is GZ? And that gets evaluated at the 0.211. Which is what? -2, -4 and 4. Isn't that -1/2 of 4, 8, -8? So we can say that NF is -2 times NG. Which means the vectors are parallel. So the normal vectors are parallel and we're done. Good. So here we have two surfaces. And we want to show that they intersect at a right angle at the point 121. If we want the surfaces to intersect at right angles at that point, what can we say about their tangent planes?
The dot product of their normals is 0.
Tell me about the planes themselves, not their normal vectors. I'll get to the normal vectors.
Their normals are at right angles.
So what about the planes themselves?
The planes themselves are at right angles.
It would suffice to show that their tangent planes are normal, meaning they intersect at a right angle. Which means their normal vectors are orthogonal. That's what we want to show. Normal vector for F. What is Fx? Fy. Fz.
Y minus 4x.
That gets evaluated at 1, 2, 1. Negative 2, 2, negative 2. Normal vector for G. What is Gx?
Minus 5.
Gy. Gz. Evaluated at 1, 2, 1. Negative 5, 1, 6. For the terms that are orthogonal, take the dot product. Ten plus 2 is 12. Minus 12 is 0. So the normal vectors are orthogonal. Questions? One topic left with multivariate functions. I also get to introduce my favorite operator. And we'll see if a physics person here will be able to determine why it's my favorite operator when we introduce it on Thursday. Well, we'll see if you recognize it as a physics major. How is the project coming along?
I have a couple questions. Let's go over them.
Be finished by tonight?